I'm Tahira Mazumde from IT department, AKGEC Engineering College, and today I'll be talking on the topic of object-oriented programming style, which deals with features related to object-oriented programming, and it comes under the subject of object-oriented design with code KCS 054 under AKTU University. And these are the contents or rather the topics which I'll be talking about today. First, I'll be talking about the elements concerning object-oriented programming. Then I'll talk more about the features related to object-oriented programming. And we'll take up C++ as an example of object-oriented programming language as per the syllabus, and then we'll talk about the features concerning C++, the classes and objects which are very important building blocks in case of C++ programming language, and we'll talk about one topic, constructors and destructors in C++. Of course, there are lots of topics to be discussed, but these are the topics which we'll be talking in today's lecture. What do you mean by object-oriented programming? Basically, we go for object-oriented programming when we try to model the real-world problem. And when you're trying to model the real-world problem, we try to keep it as close as possible to the perception of the users, the real-world look which the users look into. And that helps with easy computational environment, because we are looking at it from the real-world point of view. Another very important feature of object-oriented programming is that because of the uses of classes and objects, we tend to have software components which are reusable. This is a very strong feature of object-oriented programming languages. And because of that, it leads to easy modifying and extension of the implementations which you have already designed, which we'll be designing using C++ or using any object-oriented programming language for that matter. Now, if we want to define object-oriented programming language, we can say it is basically a programming methodology where we associate data structures with a set of operations which act upon it. So, we are basically the data structures and the operations, these two will be forming the members of an important component which we call it as class. Data structures we'll be calling them as attributes, or we'll be calling them as members, and the operators will be calling them as functions. So this is an important concept of object-oriented programming language, and as we proceed, we'll talk on this more. So if you want to define object-oriented programming, we can say object-oriented programming, we seek to define a program in terms of things in the program, that is, what are the components that are used by that particular program for the execution of the task. Like we might be working on a program which deals with data concerning cars, peoples, buildings, files, and so on. So when we are talking about programs focusing on things, we tend to go for object-oriented programming language, which relates more with the real world scenario. And we focus on what these things need and what they can do, and we try to model that using the object-oriented programming languages. This is something like this. These are the data objects on which we'll be working, and these are the methods through which we'll be working on these data objects, and we'll be writing codes through object-oriented programming language to realize the real world entity which you see in everyday life. So we can say object-oriented programming language, they basically define classes. This is a very important building block of object-oriented programming language. What are classes? Classes are components of the language which contain two important components. We call them as the data member, and the other one is the method. They have different nomenclatures. We call it as data, we call it as members, we call it as attributes, and so on. Methods, or we can also call it as functions. These are the two important components of classes. Now, through these components, through classes, we control the access to internal data and the methods concerning the program. And we have a public interface that is used by the external code when we are using the class. We'll explain this or rather we'll understand this more as we proceed in the subsequent slides. And object-oriented programming, we can say it is a highly effective way of modeling real-world problems inside a computer program, and it is easy to understand because we relate it to the real-world scenarios. So whenever we are dealing with programming languages which tries to relate to the real world scenarios, we can go for object-oriented programming languages, and that becomes much more easier to grasp. So of some of the languages, we can say there are languages like ADA, which doesn't support actually inheritance or dynamic binding. We have languages like C++, Objective-C, Simula, etc., which comparatively supports inheritance. Now we we'll be talking about there are various languages which supports object-oriented programming languages like C++, we have Python, we have Java in today's world, which people use nowadays. Now, today, as for the syllabus, we'll be focusing on the language of C++. Now, what does this, what the C++ has the characteristics is that it is a compiler-oriented language. That means we have a compiler software which converts, normally which converts the source code into the object code, which is directly executable by the CPU of the system. C++ has a feature that it is strongly typed and it is unsafe. Strongly typed in the sense that if we are using any variables inside the programming languages, we first have to declare those variables and only then we will be using those variables. So we have this conversion between variable types which must be made by the programmers, and we can make a way out also. We can also deviate from the rules, and hence we can say unsafe. And next point is, very important feature of C++ is that it is basically an extension of C. That means it is very much compatible to C. Whatever we have in C, all of this gets implicitly possible that we can also run those kind of syntax in C++. So we can call C libraries directly and C codes directly with almost 100% valid C++ code. So it is totally compatible with C. So if you're learning C, and it becomes easier for us to migrate to C++. And of course, it is capable of very high performance computing. In many cases, even supercomputers are programmed using C++. As I told, it is object oriented, and there is no automatic memory management. These are some of the features of C++ programming language. Now, when do we choose this programming language? We choose this programming language when the performance matters, when the productivity is less important, because when it comes to computation speed, working in Python, MATLAB or R, they are much more faster compared to C++. But if when you're dealing with large amount of data, multiple CPUs and all, C++ comes to help. And the programming language also, it can also help to organize the code. Like we have objects that can closely model the elements of a system, and that helps in easy organization of the codes, and through this we can also access libraries. So this is some of the instances or some of the scenarios when we can opt to choose for C++ as a programming language. So I'm now talking more about C++ features, and C++, as we know, it's a very vast programming language. So I can't afford to touch all the topics today. I'll be talking on some important concepts in today's lecture. So this is the structure of a typical C++ program. We need to, in the first part, we need to include the header files, which will be containing functions which are predefined, and then they will be called. So first segment of the program consists of inclusion of header files. Then we have classes which are used, the definition of the classes, the definition of the class functions, and then the main function programs, which will be working on the classes. This is a typical skeleton or a basic skeleton of a C++ program. Now, this is a simple C++ program. We have, as I said, it's a question of inclusion of files. The part when I told that we need to include files. So here we are including a file iostream.h that deals with input-output codes, input-output predefined functions. And then we have the main. Right now we are not going for this part. We are straight away going to the syntax of the main function. We will come to the classes and definition of classes and objects later on in the other slides. But just the main function, it is similar to C. Those of you who are familiar with C, you can see that the coding style, the grammar, the syntax is very much similar to C. So we have the main function prefixed by the return type, which we are saying it is as int out here. We can also opt for specifying void as a return type, and then inside the braces we write the codes related to the main function. Here the main function it's just very simple main program which deals with printing hello world message, and finally return 0. Now, as I told, C++ has got a number of features. Our focus will be on some important concepts. I'll be today talking on classes and objects, and then I'll be talking on some more concepts like constructors, destructors, and so on. So to start with classes and objects, what are objects? I have already talked a little bit more in detail in some of my previous lectures what objects are. So we can summarize and say that objects basically are the fundamental building blocks in any object-oriented programming language. They are runtime entities and they are associated with data and functions. Fine. And objects are basically, we map the objects to real world existing entities, and objects we can say they are instances of a class. So this is a very important point. An object, basically, if we are seeing the technical definition of object, we can say that an object is an instance of a class. So this is an example of how exactly do you define a class in case using the syntax of C++ programming language. So we have the keyword write. You have to rewrite the keyword class, followed by the class name which you will be using, and then followed by braces, opening brace and curly brace, followed by a semicolon. And inside the braces, what you will be writing? You'll be writing, as I told, classes has got two important components, the data and the methods. The data is also called as attributes, the members. So, and the next component are methods, or we can also say operations. Basically, these operations talk about the work or the kind of functionality that are being performed using the attributes or the members that we define inside the class. So we have operations which works on attributes, and these are the two important components of a class, and we define the class in this syntax. This is the syntax of how we define a class. So if you take an example, if you just see it in a graphical view, we can say a class is made up of attributes, and we have a number of operations which basically work on these attributes, which basically work on this object. And an object basically is an instance of a class. So instance of a class. So if an object, basically, if a class has attributes, this features, obviously an object of that class will be having attributes, and it will be having a set of operations which will work on these attributes. So if you take an example of a student object, let us take an example of a student object. So if you see, a student object has attributes like student name, student ID, the branch of the student, the semester of the student. So these are the attributes of the student. Next is what are the operations which are performed by the student object, and by operations, that means operations which will work on the attributes of that particular object. So we have operations like enroll. How will we enroll student? By using the student name, the student branch, the student name, all of these attributes are required. So enroll operations, we have performance which looks into the student ID, we have results looking into the result, we have display information, again working on these attributes. So this is an example of a student object having how many operations? 1, 2, 3, 4 operations, and how many attributes? 4 attributes. And this is the diagrammatic view. As I told you, class basically is a collection of similar objects. If you have, like, for example, if you are having objects which are very similar, all of these objects are basically instances, or rather by instance we mean that they have actual existence. And what do you mean by actual existence? Not necessarily real world existence, but actual allocation of memory space in the computer's device or in the computer's memory. So these are objects, and so these objects are of the same type, we call it as class. Now, so how do we actually go for defining a class? If you look more into this, we can say through this concept of a class being made up of attributes and functions, it basically goes into the realization of a very important concept of C, object-oriented programming language, which we call it as encapsulation. See, if you look at here, we have a class student, and this student encapsulates two important properties, the properties related to the attributes and the properties related to the functions. So these factors or these properties are encapsulated inside the class student, and from external from the external part related to outside the class, external segments will basically be accessing the working on the student. This components, attributes and functions will be encapsulated into the class, and how external world or rather external components of the program, how they will access this members of the class depends upon the specifications, like whether we are going for public, private or protected access. Now, if you look at it, this is how the syntax is defined for this particular example. So we are having the class name as student, the class name, this is this grammatical syntax of going for how we declare a class with member data and member functions. So the class name is student, and the member data are student name. So we are declaring student name as a character array. Student ID, we are declaring again student ID as a character array of size 10. Branch also we are declaring as a character array of size 10, and semester also we are going for declaring it as a character array of size 10. So based on our requirement, it depends what kind of data type do we initialize. Here we are taking them as character array, or rather string we can say. And the functions, we have enroll, display information, and result. So enroll function, display, result, and performance. So these are the functions that are declared inside the class. And if you see, these functions have the return type of these functions are void. This is E printed by mistake. The return type of these functions are void, and these functions are not passed taking any arguments. It's just an instance. We can have something else also. We can have the functions taking arguments. We can have the functions returning something else other than void. So based on the programmer's requirement, he or she can work on the coding part of the functions. Now, if you see the syntax, this function, it is simply declared, the definition is not there. So there are two ways of working on this member functions. The definition of this class, either we can opt to define inside the class, that is defining definition of a member function inside the class, or we can also opt to define these functions outside the class. Now, if you're defining it outside the class, then we need to take care of the scope resolution operator, which we'll be using, which I already have talked about in my previous slides. If you're declaring the functions, or rather if you're defining the member functions of the class outside the definition of the class. So when you're talking about the member functions, it is our choice whether we go for defining it inside the member function, inside the class, or outside the class. When you're defining it outside, we need to take care of the scope resolution operator. This is the brief summarization of the syntax. You have the class keyword followed by the class name. You have two important components, the data members and the member function. So this, so the class student and the member data is, let us say, these are the member data, these are the member functions. When you're not going for any, what will be the access, how will this class be accessed, or rather how will the members of this class be accessed outside the class? There are different specifications. If nothing is specified, then by default the access is public. We already have talked about this visibility mode or class specifications in my previous lectures. Public, private, protected. Public, that means all the member functions, and they can be accessed by codes outside the class. Private, they can only be accessed by the member functions of the class, and protected, they can only be accessed by the member functions of that class and the member functions of those class which are derived from that particular class. And by default, all items, if you don't specify any kind of specification or visibility, by default it goes under the category of private visibility. So here in this, if you here we are not giving the specification, in by default they will be private. So the member data, the members of the student class has got two member data, student ID and student name, and it has got two member function, read data and print data, and their visibility mode is private because we have not specified. By default it gets equal to private. Now, if we want to make it something else other than private, like public or protected, in that case we have to use the keyword public. For example, in this particular scenario, we are making them public. So you have to use the keyword public followed by the column and the members which you want to make it as public. So if you want protected, then in that case, you also will be writing it protected. You may write this public keyword here, and even if you don't write, all of these members, whatever is following the public keyword, will be having the visibility of public. Similarly, we can go for protected visibility. Now, next topic is how do you go for object instantiation. What is object instantiation? We can say the method by which we create objects of a class. As I told you, an object is an instance of a class. An object is a unit which actually exists. Class does not occupy memory. Class gives the definition of the properties of an object. So through object, we actually have the entity that is being created. So object instantiation is the process of creating objects of the type of the class which we are working on. So how is the syntax? We give the class name and then followed by the object name. For example, we have a class student, so we give the name of the class followed by the object name that we want to use. In this example, so right now we have, if you look at this previous example, here we are just defining a class whose name is student. Right now we have defined the class, we have not created the object. Now, what you do when you're creating the object, what you have to write, whatever class you have written, you can the class student, this class student followed by a variable, let us say st. So st is basically an object of type class student. So this is how we go for it. So you write the object name followed by the class name. So in this example, st is an object. So if you look at here, like here, we can say ST is an object. So once you have ST as an object, so ST has got member data as STID and ST name, because that is the member data, STID, ST name, and it has got member functions like read data and print data. Fine. So these are some more examples of objects. We have ST1, ST2, ST3. These are objects of type class student. So we have 3 objects that are, and all of these objects have this feature. Why? Because they belong to the class student, and if you see what was class student was having this particular attributes. So so in this example, okay, so here we are basically having a class, a student ID and student name. So the class has student ID and student name, not this one. There is a typo error out here. And we have read data and print data. So the functions are, so if you look at it, we have ST1, sorry, we have give me a moment. So if you look at this, we have ST1, ST2, ST3, they are objects of type student, and this ST1, ST2, ST3, the moment we create these 3 objects, each of these 3 objects will have their own members. And if you remember, the members of this student class in this example are having 2 values, 2 member data, the ID and the name, and the functions, it has got 2 member functions, read data and print data. So if you just see, each of these objects have to have their the ID and the name, which is unique to each object. For student ID 2, the ID is 20 and the name is Stephen. For student 3, the ID is 55 and the name is Mary. And for each of these objects, we have the member functions. If you remember, the member functions were read data and print data. So for each of these objects, the member functions are read data. Each of these objects have access to this member function, read data and print data. So in case of ST1, this member functions will be accessing the data 10 and Rama. In case of ST2, this member functions will be accessing the data Stephen and 20 and so on. This is how things work out in case of classes and objects. And how do you access them? To access them, we write st.std. For example, ST1 wants to access the ID. So what you'll write, ST1, that means the class, the object name dot the member ID, the member name. That's here. The member name is just give me a moment. The member name is stdid. So if you want to access this member, this object member, so what we'll write, st1 dot stdid. So a dot operator is used to access the member data of an object. So we have st object, and this is the member data of an object. And in case if you're having an array of objects, so you have the object name followed by the array index, st followed by the index of the array, like st0, 1, 2, 3. If it is st0, that means the 0th object, st1, that means the 1th object, followed by dot and the member data which you want to access via this object. And if you are talking about defining of the member functions, as I told you in this particular example, when we are going for a class definition, this is the definition of the class. And in the class definition, you have the functions, and this function, you can define it inside the class or you can define it outside the class. So this is what I'll be talking about right now. So if you're defining the member functions inside the class, what do? You simply write the member function name, the return type, the arguments and the body. This is a typical definition of how we go for a function definition. But if you're defining it outside the class, those functions, the member functions of a class, if you're defining it outside the class, what you do, you write you write the function name here, prefixed by a scope resolution operator, prefixed by the class name for which it is a member, prefixed by the return type, and then followed by the argument types and then the function body. So if you compare it, so when you're talking about definition of outside the class, this is a very important point that we need to remember. It is that because the definition is not inside the class, we're defining it outside the function, outside the class, you need to give the function name prefixed by a scope resolution operator and the class name, so that the meaning goes to the compiler that this function is a member of this class. Once this meaning is given, then the remaining things are as conventional that we use for functions, that is the return type, the argument list and the body of the function. So, and when you are accessing the member function, the same method will again use. We'll write the object name followed by dot operator and the member function, like st is the object name followed by dot and the member function is read. Similarly, if you are going for an array of objects, you use the array, you use the indexing for I, let us say sti, and you give the function name. Now, the next topic which I'll be talking about is constructor and destructor. This is a very important topic which is very much prevalent in C++ and used frequently, because C++ involves a huge number of features. I'm talking about some features in brief. So, now I'll be talking about constructors and destructors. Constructors, they are special function that is a member of a class. So, constructors are functions, not ordinary functions, but special functions. They are members of a class. And next point is they have the same name as that of the class. So, once you have a member function of a class which is having the same name as that of a class, we call it as a constructor. And we use this constructor for the purpose of initialization or creation of objects of that particular class. So, constructors, another very important rule is that constructors, they don't have return types, and constructors should be declared in the public section of the class. So, this are some important points that needs to be remembered when we are working on constructors. Like if you look at this syntax, so we are having, this is the syntax. So, for example, we are having the class name, class keyword followed by the name of the class that we are defining. This is the syntax of an example of a class where you're going for constructors. And then you have the public section, and then if you see, we are having a function. Why? How can you say it is a function? Because we are going for parenthesis. That means whenever you have parenthesis following a keyword, following a name, or following a particular word, then we say that is a function. So, class name, this name and the function name are exactly same. The class name and the function name are same. So, we will say this is a constructor. Next point is this is a constructor. Next point is it is declared in the public section. As I said, constructors needs to be declared in the public section. And another point is constructors, they should not have any return type. So, if you look at this function, this constructor is not having any return type. Not having return type, declared in the public section. The name of the constructor function and the name of the class name is same. So, these are the three important properties which you need to look into when we are working on constructors. So, if you look at it as an example, so we have a class student which has got member as student ID, and we have a constructor student fun. This is a function again, if you look at it, and this is having the same name as the class. So, it is a constructor. It is not having a return type, and it is defined in the public section of the class. So, it is following the rules that need to be followed for the case of constructors. And what does this constructor do? It initializes this student ID member to 0. So, as I told you, constructors are used for the purpose of creation or initialization of the objects of a class. So, in this case, we are initializing it to 0. So, in that case, how exactly do we call that? If constructors are functions, then how do we call them? Now, very important point to be noted is that we don't call the constructors. Constructors, they are called implicitly. Whenever you create an object of a class in the main program, implicitly the constructor function gets called. So, as a programmer, you don't have to call them explicitly. So, we have a class student, you have the member data student ID. In the public section, if you just see, the class name matches with the student name, with the function name. So, it's a constructor, and in this constructor, what does it do? It sets the member ID to 0. So, how is it called? The moment in the main program, the moment you create an object st, what happens? The constructor will be called, and once the constructor, so st, an object is created, so it will be having two member data, that is st id, and another member data is student, right? So, the moment this st object is called, or rather created, the constructor will be executed, and the constructor, what does it do? It sets the student ID to 0. So, once an object st is called, what will happen? By default, implicitly the constructor will be called, and the member data of this particular object st, so st id will be set to 0. This is what a constructor is doing right now. A constructor here is initializing the member data st id to 0. So, this is an example of a constructor. So, if you look at this, you have a class stud, and just see you have the member function, same name as the class, and we have two members m and n. So, this is equalizing both of these members to 0, and we have a display function which displays the value of m and n. So, in the main program, what we are doing, we are creating an object s of class type stud, and then by the moment an object is created, the member data gets equated to 0. So, when you are going for display function, that is when you are printing the value of m and n, the value of 0 will be printed. Now, there's some types of constructors which you need to look at: parameterized, overloaded, default, copy, dynamic constructors. Parameterized constructors are constructors where we pass arguments or whether we can pass parameters. In the previous example, we did not pass parameters. We can also have constructors where we are passing arguments or parameters. So you have the class addition, you have the member function having the same name as the class name. So it's a constructor and we are passing arguments. So this is an example of a parameterized constructor, and this constructor using the value of a and b as an argument, it can work on this member data of the class. This is a simple program which works on this on parameterized constructor. So we have clustered and you have the same function name as the class name. So it's a constructor and you have got two member variable x and y. You are passing two parameters as x and y. And what does this constructor do? It initializes the member m to x and initialize the member n to y. So, and the display function displays the value of m and n. So if you look at it, this is how we call a constructor with parameters. We write the object name within parentheses. We give the values of the parameters. Now we are sending 5 and 6. That means 5 stands for x and 6 stands for y. So 5 and 6 is sent, and so the member value of, in case of S object, its member value m and n will be set to 5 and 6. And so when you are going for display function, the value of m and n, which is 5 and 6, will be automatically printed. This is an example of a constructor with default arguments where you have variables, constructors with arguments. Like if you see a and b here, b we are setting the default value to 0, and a it is a value of a variable which we can initialize. Like what does it mean? Constructor with default arguments. That means we need to pass two arguments a and b when you are calling this constructor or when you are creating object of this class. And in case if you are not passing two objects, if you are just passing one argument, then the value of a will be set as that argument value and the value of b implicitly will be set to 0. Like for example, let us say if we are taking a class, let us say example, and where you are having two arguments. Out of these two arguments, the default argument is b, which is set to 0. Another point that needs to be remembered is that the default argument should always be declared in the rightmost part and an argument a. So when you are calling this, creating an object, let us say you are creating an object E1 of this class. If you are passing only one argument, so a will be set to 5 and the value of b will be automatically 0. But if you are passing two arguments, in that case, a will be set to 5 and b, which was 0, will be reinitialized to 3. This is how it works. In case of copy constructors, what you are doing, this is your class name, the constructor name. We are passing an object of the same class type and we are trying to copy the values of this object, or rather we are trying to create a new object which will initialize the member using an object which you are passing it as an argument, using a class object of the same type of the class. Like for example, if you look at it, we have a clustered, the same class which you are talking. Here we are passing an object x, which is an object of the same type of class. And so what does this x do? We are initializing the member m and n by the members of x. X is an object of this particular class, so x will also have two members m and n. So the m member of x is used to initialize the m part, the n member of x is used to initialize the n part. And what does the start? And so we have in this example, so we have two constructors. One is a constructor which is having copy constructor, the another one is a constructor without any arguments. By default, the values of m and n in that case will be set to 100. And we have the display function which displays the values. So this is an example of a case of copy constructor. Example of overloaded constructors, that means you can have more than, this is a class name, this is a constructor function. So overloaded constructors means having more than one constructors with the same name. In one case we are having two arguments, in the other case we are having again two arguments, but the difference is in one case it is integer data and in the other case it is floating point data. So based on the kind of parameters that we are passing, creating an object, if you are creating an object and pass, like for example, we are creating an object addition, this is your class name, and we are creating an object 5, 5. So 5, 5. So here we are passing integer. So in that case, the first the first constructor will be called. Now, if you are passing 5.5, 5, for example, so in that case, we are passing floating point data. So in that case, the second constructor will be called. Fine. This is a case of overloaded of constructor, same thing. So we are having more than one constructors, that is overloaded constructor. In one constructor we are going for copy constructor. In another constructor we are going for normal constructor, which initializes the values of the member data to 0. And the next is the constructor with parameters, where we are passing arguments which will be used to initialize the member data of that class. So when you are calling in the main function, when you are creating an object, if you see, we are creating 3 objects, S1, S2 and S3. In S1 we are not passing any argument, so it will go for this particular constructor. In S2 we are passing 2 arguments, so it will go for the second constructor here, X and Y. And here in S3 we are passing an argument which is an object and another object of the same class, so it will go for copy constructor. So this is how we go for overloading of constructors, and we are calling the display functions. Obviously it will display the values correspondingly. So when you're going for S1 display, it will display the values of, if you remember, it is setting to 0, 0. So in that case, the MN value N will be 0, 0. Here the value will be 400 and 500, because S2 we are passing the parameters X and Y, which is setting the value to M and Y. And since S3, in S3 you are copying the value of S2 and you are trying to go for display of S3, so it will be displaying as 400 and 500. Now, distractor is another special function which is taken in parallel whenever we are talking about constructor. It is a member of again a class, and it also has the same feature. It is having the same name as that of the class name, but unlike a constructor which is used to initialize or create an object, distractor is used to destroy the object. And again, destructors, then they need to be declared in the public section of the class, and destructors, they don't have arguments and return types. So, and normally you can have a number of constructors in a program, but you can have only one. These are the references which I have used for referring this topic. Okay, for now I wind up. Thank you so much.